Said Ronnie Vasishta, SVP of Telco, Telecom at NVIDIA. Very pleased to be with you here today. Let me start off by saying the future telco is an AI native telco. Easy to say, but as I'm going to go through this in the next 40 minutes or so, it's actually starting to show how we can make that happen. But we've still got to go through a few transitions to make that happen. So firstly, the concept of an AI native telco is a telco that's able to leverage AI for operations, for customer experience, and for the acceleration of innovation. And for those of you who are telcos or been in the telco industry, you know that often it's hard to really innovate when you're also having to operate. So as we've seen in NVIDIA, this AI era that we're entering into has really been an exciting era for telcos. 150 telcos around the world, 90% of the top 50 telcos are now working with NVIDIA. In a recent report that we commissioned, or that we carried out earlier this year, 97% of the 450 telecom professional respondents said that they are already using or planning to use AI. Let's understand why as we watch this video.
For decades, telecom networks have been the lifeline of our world. Always there, always reliable. But now, we are at the tipping point for the future of communication. Telcos are evolving into something more. AI-powered grids that don't just connect. They think, adapt, and solve. Customer experiences and network operations are being reimagined with AI agents. AI factories are accelerating research, redefining innovation, and unlocking new possibilities for industries and nations. What were once simple relays are now AI powerhouses. Cell towers transforming signals into intelligence for billions. 5G and 6G are being trained, simulated, and deployed with AI, making every connection smarter, every interaction more seamless. This isn't just an upgrade, it's a renaissance. Telcos are no longer just the backbone, they're powering what's next in physical AI, robotics, and beyond. AI is defining our future, and the future moves on telecom networks. The only question is, how far can we go together?
The question of how far can we go together? Let me ask you a few questions as we get into this. Do you believe that one day we will all have the ability to talk to our agent on our phone? That we will all be able to do this? Thousands of people at a time, millions of people at a time. If you do, then you know that the connectivity to enable that to happen means millions of links. Do you believe that our cities and our spaces will be safer because of video traffic? That video search and summarization at the edge of the network will be able to provide insights into traffic patterns, into alerts about issues happening? That video needs to be uplinked at high data rate to an edge network for that action to be achieved. Again, millions of high bandwidth connections. Do you believe that robo-taxis will be deployed across the nations? That these robo-taxis will need to know where they are at all times, and sometimes take actions depending on where they are. Again, millions of real-time or near real-time connections? And do you believe that our spaces, our private spaces, our public spaces, like ports, like airports, these will all have some form of robotics, whether it be drones or automated robots for manufacturing or other types of applications, will all need to be connected. And we'll need to get insights and retrain those robots. And do you believe that the next frontier of our society will be driven and enabled by the access to robotics, whether it be at the home or in business? And these robots will need to be connected, often connected to each other, but many times connected to a network, such that we know where they are, what they're doing, and we can retrain them and deploy that retraining into their brains, as we saw from Jensen yesterday. Well, if you believe all of that, and if you think about the last time you were at an event and you tried to get a connection on your phone, you tried to uplink video to your friends or family, you can see the journey that we need to go through. And we need to go through it very, very quickly. AI gets us there, and AI accelerates it. We will have to have hundreds of billions of connections, real time, near real time, and how does that happen? So telecom networks, and this is a key phrase, really become the intelligence fabric. Not just the connectivity fabric, but the intelligence fabric across consumers, enterprises, nations. They transition from just having just connectivity, but to intelligence embedded within that connectivity, so that we can connect to those healthcare, to education, to transportation, to all the things that we know are critical. But we can also embed compute, embed intelligence into those networks. This transition from connectivity provider to intelligence fabric provider is a transition that is enabled by software-defined networks. So if you think about the muscles that telcos have today, there will need to be some strengthening of those muscles. And we're starting to see that strengthening already happen, as I'll come on to. And we will need to build some new muscles. Sovereignty. Telcos are really trusted as the critical providers of critical infrastructure within their regions. They're trusted. The last mile reach, whether it be broadband, whether it be wireless, that last mile reach is often the domain, the critical domain of telcos. And one thing that's really, really critical is determinism in the network. When you think about near real-time applications that I talked about, the compute cycle that's required there as well has to be as deterministic as the connectivity. Telcos have the determinism capability. And now there's a whole new muscle development that needs to happen, and that's an ecosystem. Some of that's starting to happen. And we're seeing today how that ecosystem is starting to transition into an AI native approach. Critical also is the use of a homogeneous infrastructure. This is one infrastructure, hardware and software, that is flexible and that can be provisioned for use and can be upgraded in a flexible way. I'll come on to what I mean by that right now. That's the first building block of what it takes to be an AI native telco. A homogeneous, scalable, accelerated infrastructure for any workload. Of course, there's hardware at the base of that infrastructure. Actually, you could even say the base is real estate and power. And we built hardware as a result of having that base. But on top of that is a disaggregated software layer that can access that hardware. And that disaggregated software layer, we can run applications, an application like radio access network, but also some of these applications that you saw talked about in terms of the libraries that Jensen talked about in his keynote yesterday. So the good news is that this isn't all the future, it's the now. 18 telcos around the world have moved from only generating revenue by ARPU to move to generating revenue by tokens. It's happening. Telcos have found that new revenue stream. They are already, depending on their region, they are dependent, they are sovereign, they are trusted deployers of critical infrastructure. They are also providing the ability to generate, as I said, new revenue. But the key thing in all of this is that the telco themselves are developing those muscles to enable them to provide that infrastructure in their region. Let's just go through a few examples. Swisscom with their Swiss AI platform really built that infrastructure back in November of last year. Sounds like a long time ago, as GPU as a service. They've transitioned through that GPU as a service, and we're able to now, in January of this year, have an AI work hub where they could bring in and really develop AI applications. And as they go on this journey, moving to more platform as a service as well. Also, Telenor working with Capgemini has developed on their infrastructure the ability to provide 100+ instant translation languages. How critical is that? With the first example being the use of the Red Cross. This is an enterprise that's already taken advantage of the infrastructure and a partner that's developed a really, really useful application on top of it. And Fastweb is on to version 2 of their MIA Italian language model. Just some examples of how quickly we're moving through. And I'm very pleased to announce that Orange has joined the NVIDIA Cloud Partner Program. The NVIDIA Cloud Partner Program is a program by which we're able to transition very quickly a company through that learning cycle. But Orange themselves already have transitioned. They have taken their live intelligence platform that was developed and proven and learned using that platform internally with all their employees, now taking that out into the open market. And so learn by doing is a really good way of thinking about how to develop those muscles as you go to market with generative AI solutions to the enterprise. Trusted is really critical for this service. Responsible is really critical for this service. And of course, accessibility, created by the infrastructure and the connection to businesses. STC Solutions. STC Solutions is already announced that they're becoming an NVIDIA cloud partner. STC Solutions will be developing and delivering their services in their design center this year. This is starting off as GPU as a service, but also moving to platform as a service. A very wide reach STC Solutions has, and now is adding their services capability to the NVIDIA Cloud Partner Program solutions as well. Hardware and NVAIE and the NIMs and everything that goes on top of that. A very interesting example of this new muscle development of infrastructure deployment is Telefonica. Telefonica is going to be deploying, as part of the NVIDIA program, NVIDIA Cloud Partner Program, the distributed intelligence, meeting the requirements and conforming to those of some of the digital initiatives within Spain. The distributed infrastructure provides infrastructure closer to the point of use, but also is enabling data sovereignty for the enterprise that's using that infrastructure. So building block number one was the homogeneous infrastructure. Building block number two is the enablement of, if you remember what I said before, those autonomous operations. It's autonomous operations for networks, customers, and employees. So the ability for a telco to take the large language models, deploy those large language models, really started off in some customer experience engagements. And of course, that's very important, and transitions across industries. Now, as we're entering the era of reasoning, we can start to see how agentic flows are becoming really critical to network operations. This is perhaps one of the most critical areas of any telco, and reasoning enables that to happen. I'm going to show you a few very, very interesting examples of how our partner network, already 10 partners today, have developed network operation solutions based on agentic flows across at least 50+ different applications. But just some examples of the performances and capabilities that we're already seeing. A 2x ROI, a 22% capital savings, a 63% average cell handling time, and a reduction in mean time to resolution. These are real-world numbers that are being achieved already. I'm very pleased to announce that NVIDIA is now releasing our first AI blueprint for network operations. This is an incredible step forward. The telco AI blueprint is enabling network engineers to reconfigure and configure parameters for the first time through an agentic flow. If you think about the complexity of configuring parameters and how you can now do that in an automated way through an agentic flow, it really is the essence of AI, making something so complex, so simple. And the ability to do this real-time, dynamically, something that normally takes days to do. You can adjust the network dynamically to changing needs. The blueprint comes in the form of course, documentation, reference architectures, and is nymified to enable ease of use and high performance. A really important step forward for network operations. Our ecosystem and the ecosystem of partners that we're building is second to none. And many of these partners focusing on telco because telco is in such need of AI. So I'm very pleased to announce that Accenture is announcing their Network Operations Center Agentic AI app. Think of this as a hierarchy of agents. Super agents, and then think of it as the worker agents below. Constantly in communication, all actually being able to be visualized through a digital twin technology. And really the first implementation is to assist ticket deflection and alarm suppressions. Also pleased to announce, TCS is bringing to market their AI native telco suite. The AI native telco suite is really, think about as being able to deal with network operations, customer experience, and IT. And these agents are now building upon the large language models, the NeMo and NIM. It's a really advanced operation that TCS is able to bring to their telecom suite. Infosys. Infosys is announcing their smart network assurance agent. This is a network assurance agent that uses both Mistral, so reasoning models built on Mistral, and reasoning models built on Nemotron. This agentic flow is able to leverage reasoning to be able to build a full guardrails as well. NTT Data. Thank you to those in the audience from NTT Data as well. We're really pleased to announce the end-to-end network alarm management. This is where network alarms that traditionally come off a network from the network equipment providers now are being able to be dealt with, in this case, really for autonomous operations. And the first case is, as I said, end-to-end alarms management. Really critical in a network operation that an agentic flow can take care of many of these alarms that are very complex and very hard to decipher otherwise. Prodapt. Prodapt. Think of it as 3 personas that have nine agents below them. The field engineer, the network operation center engineer, and the network engineer. These engineer personas are taken care of in an agentic flow that are all talking to each other. You can see many of these are quite complex, but the NIM that underlines this enables these agents to be deployed efficiently and at high performance. So this is called Agent Squad. So the building block number 2 was really the ability to provide automated operations on that infrastructure, which is a homogeneous infrastructure. Now, if you think about building block number 3, building block number 3 again uses that homogeneous infrastructure. Now we're building a network. A network that is able to really do that last mile connectivity. That we're able to build both 5G and going forward, AI native 6G on top of that infrastructure. So we've talked a little bit about the create aspect. We've also talked a little bit about the consume aspect. Now, within that network, remember that intelligence fabric network, we're now going to talk about the distribution piece of that. How do we gain access? How do we distribute that intelligence across that intelligence fabric? So on this network, there's really 2 types of traffic. Traditionally, there has always been voice, video, data. We now have AI traffic going over the RAN, the radio access network. But we can also have traffic coming from the central data center as well. So there's endpoints, traffic coming over the airwaves, over broadband, and now there's also traffic being diverted to those distribution networks. That actually is quite a powerful capability. Because it's a homogeneous architecture that's software defined, we're able to distribute that intelligence across all of that continuum of what you can call the grid. And when it comes to inferencing, which we already are doing often by the cloud, the service level agreements required for many of these applications will require that intelligence to be located at different points in the network. I'll come on to a little bit what I mean by that. It's not just latency, but the ability to provide that homogeneous infrastructure that can be provisioned according to use models, according to time of day, according to performance and SLA and priorities as a software-defined orchestration is really critical. So I already started to talk about 6G. Why? Because 6G standards are being formed now. There's already been the first 3GPP standards meetings where 6G is being defined. And some of the key tenets that are coming out of those discussions, firstly, they're all built on AI. So the ability to leverage AI for the 6G standards was unprecedented in previous generations. But when you think about the limited amount of spectrum that we have, spectral efficiency is very, very important. We also, to improve spectral efficiency, we create these concepts of integrated sensing. Traditional networks, wireless networks, have delivered essentially based on a static algorithm. But that doesn't make any sense. The world is changing. Rural environments are different. Sometimes it's got thousands of people, sometimes it doesn't. It rains sometimes. There's trees in certain areas. What we can do now is use the radio network as a sensor to sense all those applications and dynamically adjust by having AI ML in the signal path, the spectrum availability and the spectrum usage. Just think of that. Spectral efficiency created by AI. Of course, the inclusion now of non-terrestrial networks as an overlay to the cellular network. And something that's really, really exciting is the use of semantic communications. We're already seeing research that we hope will get into the deployment. Just think about semantic communications. I don't need to transmit 1,000 bits, I can transmit 1 bit because you know what I'm going to say, you know who I am. Why do I need to transmit everything? I can reconfigure using AI at either end. A tangential shift. Let's see just a video that explains some of this.
The journey to AI-native wireless networks has begun. Traditional wireless systems rely on fixed algorithms that are hard to scale and slow to adapt. NVIDIA AI Aerial changes that. Neural networks learn from data, adapt in real time, and scale with complexity, boosting spectral efficiency, lowering costs, and improving connectivity. Building AI-native wireless networks takes 3 key steps: training, simulation, and deployment. NVIDIA AI Aerial unifies all 3, making it easier to build, test, and deploy AI models faster. Here's how it works. We train a neural network model using NVIDIA Shauna and aerial radio frameworks. This model replaces the traditional 5G channel estimation algorithm. Next, we simulate and optimize it at city scale, testing thousands of real-world scenarios in the Aerial Omniverse digital twin. The result? Nearly double the cell throughput with AI on. Then, we deploy the trained model on a live 5G network at NVIDIA using Aerial RAN computer. The result? 100% higher throughput with AI. Because the model connects to a digital twin, it keeps learning, continuously improving over time. This feedback loop between the physical and virtual worlds helps the AI evolve faster and get smarter with every cycle. With the Shauna Research Kit on NVIDIA Jetson, developers can go from code to a working AI model in a live 5G network in few hours with just 6 lines of code. This is just the beginning of AI-native wireless networks. As models improve, they'll boost capacity, unlock new applications, increase efficiency, and extend coverage to more people. Join the NVIDIA 6G Developer Program to accelerate your AI-native wireless research.
Who thought that was amazing? The world is really about to change. We just don't know how much it's going to change. We're starting to see the ability to connect, as I said, all of those billions of things is starting to really happen. It's not just vision anymore. This journey, while it sounds like it's been a long time in coming, it actually is accelerating rapidly. What we call AI RAN, not we, the industry, the telecom industry, not NVIDIA, but AI RAN. AI RAN is the fusion of AI and the radio access network. It's really, as I said, gaining pace. We've seen the NVIDIA 6G developer program, as mentioned here. And by the way, you can go see that demo on the floor in the NVIDIA booth. I encourage you all to go see that. The 6G developer program accelerated from in a year to over 2,000 members. We've also engaged with some of the leading industry luminaries in forming the AI RAN Alliance, which went from initial 10 members just over a year ago, now officially 75 member companies. We're really speeding through these new partnerships as well. Recently, we announced the AI Win project in the US with some key partners there. The sole point of that is to develop blueprints for the AI native 6G that can be put forward into the standards. And we have some network functions being also developed in our ecosystem on top of the NVIDIA hardware, and really pleased to see some of our key partner names on there. But not just that, we have some telcos that are really leaning into this concept of not just what I mentioned earlier, which is the AI infrastructure for token generation for monetization, but also really leaning into the fusion of AI and RAN together. Indonesia, IOH, they have 280 million or so people in the population spread across archipelagos. Why wouldn't they fuse AI and RAN together to deliver education services, health services, using AI to their population? T-Mobile in the US, that's working on the ability to put in their mobile switching offices AI and RAN together. SoftBank, who's already demonstrated the importance of latency at the edge in Japan on some of their field trials. So at the key of all of this is now continuing on the theme of homogeneous infrastructure. We now build the software-defined radio access network stack on top. Traditionally, as we all know, the radio access network has required a proprietary network, a single-use network. It delivers RAN, and that's what it does. And telcos around the world spend billions of dollars of CapEx on that and monetize it through connectivity. Now, that same infrastructure, you can run AI applications and monetize through tokens. And it's provisioned accordingly. As you go out onto the floor, you'll see different formats of our hardware architecture. The same applies here. Aerial RAN computer you saw can be racked and stacked in a mobile switching office, can actually sit out at a base station. But if you're just running RAN and a small amount of RAN heavy and a small amount of AI, why not use the Arc Compact? It's a small, low-power system that can sit at the base of a base station and can run AI if needed. The video you saw earlier and what we talked about with regarding 6G, I'm really, really pleased to announce that there are many researchers across Europe, 200 institutions in 33 countries across Europe that are already leveraging NVIDIA tools and capabilities to do their fundamental research and their best work and create their breakthroughs. The democratization of this research is vital. research shouldn't just be in the domain of a few, because that's often not the way the best ideas come to production. So we've now got 190,000 downloads of what you saw on there, Shiona, which is a link layer simulator that can run on any infrastructure. I'm very pleased that earlier this week we announced a relationship with the Department of Science, Innovation and Technology in the UK. Specifically, that MOU that we signed is bringing a very close partnership between NVIDIA and the key academic research institutions across the UK together. And DCIT is empowering that collaboration. And we are bringing these tools and capabilities to those researchers. This is just one of many ways that we are bringing AI skills to those people, and AI tools, and AI infrastructure to those researchers and those people that need it. The fourth building block of an AI native telco is, as you would imagine, a digital twin. Digital twins enable simulation. You saw the three-computer system. The three-computer system requires a physically accurate, often photon-accurate environment in which you can simulate. Exactly the same is true for the wireless world. The laws of physics apply to RF. We need to know how RF reflects, is absorbed, refracts from properties such as concrete or glass or foliage in different weather systems. This can all now be done within the digital twin. But as I mentioned earlier also, digital twins are also used for network operations and the visualization of network operations. Now you're starting to see what I mentioned earlier, is that the fusion of network AI across all parts. The network and the operations can be simulated and visualized within the digital twin. So what we're really saying now is that AI native telco brings many layers together. The infrastructure layer, the networking layer. Think about that as the distribution layer, the inferencing layer, bringing in external AI workloads, for instance. But then the agentic flows that work on top of that layer on the same infrastructure. You've seen network operations, customer experience. These are critical to really deploy. And then, of course, the connectivity to consumers, to enterprises, and to nations. This is the template for an AI native telco, building at scale new efficiencies that enable us to achieve those early concepts that I showed you. And it's happening now. What we need to do, what you need to do, is decide when and where do you get onto this journey. Many are already on the journey. The question isn't if now, the question is when. The destination of an AI native telco is not far away, and I'm very pleased if you're able to join that journey with NVIDIA. Thank you.